Good morning. In previous sessions, we have seen communication system, elements of communication system, and different types of signals. In today's session, in continuation, we'll be observing modulation process. If you observe the definition of modulation, it is a process where the characteristics of high frequency carrier varies in accordance with instantaneous values of modulating or message or baseband signal, where the information originates from source that will be applied to the transmitter. That information is actual information or message signal. We all know that, for example, if we take it as voice, it is very low frequency signal. Now we need to transmit this low frequency signal one source to the other destination. In this process, we will go for modulation technique, where we will be using another signal known as carrier signal, where it is a high frequency signal. According to this high frequency signal, the characteristics of this signal will vary with respect to input modulating signal. That is the process of modulation. In general, we will say that where modulation is a process converting the low frequency signal into a high frequency signal. Means we are superimposing here the low frequency signal onto a high frequency signal, so that the characteristics of high frequency signal will vary with respect to input message signal. As we will use this process in our transmitter, then we have types of modulations. Like, first it is divided into two: continuous wave modulation and pulse modulation. The simple difference between continuous wave modulation and pulse modulation means the carrier signal. In continuous wave modulation, the carrier signal will be a sine wave, continuous signal. But in pulse modulation, we will observe we will be taking our carrier signal as pulse. That is the simple difference between continuous wave modulation and pulse modulation. Under continuous wave modulation, we will be studying about our amplitude modulation and angle modulation. Again, the angle modulation is a combination of frequency modulation and phase modulation. Angle, where it is measured by the x-axis, the frequency and phase. So, it will consist of frequency and phase. So, we will call it as frequency modulation and phase modulation combinedly as angle modulation. Coming to pulse modulation, under analog modulation techniques, we will be observing PAM, PWM, PPM, where PAM means pulse amplitude modulation, PWM means pulse width modulation, PPM means pulse position. Under digital modulation, we will be seeing our pulse code modulation and delta modulation. These are some types of modulations. In future sessions, we will see about first continuous wave modulations, AM, FM, PM. In the next module, in one module, we will observe about amplitude modulation. In the other module, we will discuss about frequency modulation and then phase modulation. So as we have seen the types of modulations, we have amplitude modulation, frequency modulation, and phase modulation. Actually, if you observe why it is divided into three types like amplitude, frequency, and phase, as we are observing here, if you take any signal, we will be having the characteristics. So, what are the characteristics of signal? Means simply we can measure our amplitude, we can measure frequency and phase. So, due to that, depending upon the characteristics of signal, we can say our modulation is divided as amplitude modulation, frequency modulation, and phase modulation. As I said, in our modulation, the definition of modulation is characteristics of high frequency carrier signal will be varied with respect to input message. So coming to that characteristics, any signal will be having amplitude, frequency, and phase. Then now coming to the definition of amplitude modulation, I can say specifically here, amplitude of the carrier is varied in accordance with the instantaneous values of modulating signal. Obviously, the frequency modulation means here specifically the frequency of the carrier signal is varied in accordance with the instantaneous values of modulating signal. Then phase of the carrier is varied in accordance with the instantaneous values of modulating signal. Then what about the remaining characteristics? Means if it is amplitude modulation, the remaining characteristics like frequency and phase will remain constant, only the amplitude will varies. But coming to angle modulation techniques like frequency modulation and phase modulation, a little bit variation of angle will be there in frequency modulation. A little bit variation of frequency will be there in phase modulation, but the amplitude remains constant. In amplitude modulation, amplitude will vary, frequency and phase remains constant. In frequency modulation, a little more variation of frequency will be there, but a little bit variation of phase will be there, but the amplitude will remain constant. Same thing with phase modulation, the amplitude remains constant, where more variation of phase, but a little bit variation of frequency. We have so many advantages of modulation. Why? Because due to modulation, we can reduce the height of an antenna. Multiplexing will be possible in modulation. We can reduce noise effect. To avoid equipment limitation also, we can go for this modulation technique. So these many advantages we have. In detail, we will see one by one. Reducing the height of antenna, we can practically prove by using a simple equation like velocity of light V equals to c by lambda. Thank you for the listening. In the next session, we will see about our types of modulations. So as I said that length of an antenna or height of an antenna, how we can reduce where h equals to c by lambda. C is nothing but constant, lambda is nothing but we can say the wavelength means frequency. So here if you observe, height is inversely proportional to frequency. So in our modulation we will be increasing or we will be taking a high frequency signal to convert input low frequency into high frequency. As the frequency is increasing, as the height and frequency are inversely proportional, we can say that the height will be reduced. So this is one of the major advantage and need for modulation. As we reduce the frequency, means low frequency signal, it requires more height of an antenna. So If we go for modulation technique where we are converting our low frequency into high frequency, so that automatically we can reduce the height of antenna like h equals to c by lambda, where height and frequency are inversely proportional. By this simple equation, we can prove that antenna height will be reduced with increase of frequency. In our next sessions, we will see the types of modulations. Thank you. Thank you for listening.